In this exercise, we have to compute the following limits. There are three of them, and each of them is a 3D vector. And what we do is we take the limit component-wise. Let's start with A. What I've done is taken the limit and put it inside in each component. So now we have three limits to compute. Let me just get some more space here. First component is a cosine. Not of t, of pi t, but everything is continuous here, so there's no problem in just substituting t equals 2. So what we get for the first one is plug in 2 instead of t, so we get cosine of 2 pi. For the second one, well, you know what, I'll continue with the first one. And cosine 2 pi is the same as cosine of 0. It's just 1. Here also, t minus 2, continuous function, exponent is continuous, everything's continuous, so we just substitute t equals 2. So we get e to the power of 2 minus 2, and that is equal to e to the 0, which is 1. And now we come to the third component. Here we can't just substitute, because when t equals 2, the denominator is 0. And as a matter of fact, so is the numerator, which is good because now we can use L'Hopital's rule. What we do is replace this with a different limit that's going to be equal to it, where we differentiate the numerator and the denominator. So we get 1 over 2t. Now, when t goes to 2, 2t goes to 4. I mean, there's no problems with this. This is continuous at t equals 2. It only has problems at 0. So it's 1 over 4, and that's the answer. This time, instead of the angular bracket notation, we have the IJK notation.